Hello everyone, welcome back to this channel, and this is the sliding window series going on. This is the another problem which I am going to solve today. It is the longest repeating character replacement. So before this, based on the sliding window pattern, we have solved some more problems. Like in the last video, which we have solved the problem that is longest substring without repeating characters. It means if any of the characters frequency goes beyond one, then in that case the window becomes invalid, and we have to shrink that window. Otherwise, it remains valid. And similarly, second last problem which we have solved was the longest substring with at most k distinct characters. So in case of the distinct characters becomes if they remains less than equal to k, then in that case the window was valid. Otherwise, again we have to shrink the window. So this is how what I am trying to say is that the idea remains the same in the problems, like in this sliding window pattern. The idea remains the same, only the condition changes. So again, with this new problem, let's firstly read the problem statement, then we will move ahead that how we have to solve this problem, like understanding the logic. So this is the another problem which we are going to. First of all, let's read the problem statement. We are given with a string s consisting of the uppercase English letters and an integer k. Then we can replace at most k characters in the string, and we have to return the length of the longest substring that can be made of the same letter after performing the at most k replacements. So this is the input string we are given with, and here they have given the output in the example. So let me just explain this in brief, that what we are given is we are given with an input string s, and these all are the uppercase English letters, and we are given with an integer k. Now what is this integer k? So what is this integer k? The integer k is nothing but it is just telling that uh, how many at most k replacements, how many at most k characters we can replace in the string, so that we can form a substring, or we can say a longest substring in which is containing all the same characters. So here it is also mentioned here that we have to return the length of the longest substring that can be made of the same letter after performing at most k replacements. So let us consider an example here. Let's say we are having this example AABA. This is the example we are having AABA, and now I am just asking that what are the number of replacements we can make here so that all the characters will become all same characters. So we can see here that one character B is here. If we replace this B with A, so all the characters will become A, and then we can say that this is the longest substring possible which we can get, which will contain all the same characters. This A. So this is what the example, this explanation is given here, that we can just replace this one B with A, so that it can become all A's, and it will just give us the longest valid length of 4. So this is the simple example we can take it. What I'm saying here is that we need not to perform any of the explicit replacements or something. We just have to come up with a way that we can find the possibilities that if we can replace any of the characters in order to form that kind of substring, that longest substring with all the identical characters. That way, that possible way we have to find. Okay, so let's build this concept slowly. So already we are having this string, and I'm just saying that if we are having this string AABA, and we already know that we are having an integer k, it means how many at most k replacements we can make on this particular string. So let's just consider that this is a window, and in this window I am saying that we are having a particular character which is appearing majority of the times. And if I just take this window length, means the window size I am taking, that is 4, and the majority of the time a particular character is appearing, means A is coming 3 times, and I can just take the difference of that window length, means window size, and this most of the times this character repeats that number. So whatever that number comes, that will be the remaining characters which are to be replaced. So here A is appearing 3 times, means most of the times. Window size is 4, so 4 minus 3, that will come 1. So it means one character is remaining in this particular window. If it is replaced, or if it can be replaced, then it can just form a particular substring which is having all the identical characters, and we can take its result into consideration. So that's what the concept we can form here. So what we have to just do is, whatever the window length is there, window length minus whatever the majority, we can call a character is appearing majority of the times, and I can call its frequency as max frequency. So this is the max frequency of that particular character. So whatever the difference comes, that will be the number of remaining characters which can be replaced. Now, whatever the number of characters comes, let's say that particular value is n. Any of the means n number of characters are coming which can be replaced. Now, if that particular number is greater than k, which we already know that how many times or at most how many at most k replacements can be formed. That k is given. If this particular number is greater than k, it means, for example, if k value is given 1 in this particular example, so if only one character can be replaced, if that value which is coming here means the number of characters which are remaining, if that is greater than 1, obviously we cannot replace that number of characters because the constraint is not allowing us to do that. But if it is less than equal to k, it means there are some of the characters means or the number of characters which are less than equal to 1. It means we can replace those particular characters in order to form a substring with the identical characters. So that's what the thing we have to do, and from here itself we can come up with that condition, that is the window length, minus max frequency. So this is the condition, and if it is less than equal to k, in that case only we can say that okay, this is the condition which is true, and we can say that the window is valid. Otherwise, obviously the window will become invalid, and in that case we will have to shrink the window, as we have done in the previous problems as well. So this is the simple case, or we can say the condition which we have with which we have to come up, because all these problems, as already I have told initially in the starting of the video, that all the problems based on any of the pattern, currently the sliding window pattern, all the problems are having the same idea, only the condition is changing. So we will see more when we move ahead in this particular problem. This is the example we are going to see here, and with the input string given with this, and we have to just find the longest substring with all the identical characters we can have. So that length we have to return, a length of that longest substring. What we have to do here is that we are having this input string, and we will just side by side what we have to do. Again, the sliding window, the same structure is there, same pattern. That first of all we have to expand this window, and means with the help of right pointer. And while expanding, we will just take the two things. First of all, the characters frequency, means frequency of every character we are taking, and along with that we will be also updating the maximum frequency, means what is the frequency of a particular character is maximum, or we can call it a majority times a particular character is came. So that thing we have to update. First of all, let's take the frequency map here, and let me just name that frequency map with the name frequency map. This is the frequency map, and along with this we will have to take two things. First of all, frequency variable I will have to take here, and first of all I will just mark it as to initialize it with 0. This we have taken, and the second thing we will have to take is the max length, means we have to update the substring, the maximum length of the substring. For that max length variable we will have to take. Now starting with the right pointer, as we have to expand the window, so first of all we will just take the start at from the right pointer. So here a character will come, and this a character will come along with its frequency count as 1. Now we will just update how we will update the max frequency. Let's see that. So whenever we take a particular character and put it inside the frequency map, we will just take its frequency and we will compare it with the previous max frequency. If it is maximum, means whatever is maximum out of both, that will be updated. Here we can see the max frequency, previous one is 0, and current max frequency for this current character which we have put it inside the frequency map, its frequency is 1. So right now in the entire frequency map, or we can say in this particular window, which is the character which is appearing most of the time? So that is a as of now. So this is the a character, and we will just update its frequency, that is 1. Okay. And after this, what we have to do, as I have already told, what is the formula or the condition which we have to check is, first of all, we already know that this is the window length. Okay, so what we can see here is that this window length is 1, and max frequency means a particular character which is appearing most of the time. So that is a, which is appearing for one time. So 1 minus 1, 0, and 0 less than equal to 1, that is true. It means the window is valid right now. So we do not have to do anything in this. We just have to take its length into consideration, and we can just update it inside the max length. Okay, so here the max length will be updated right now, and this right minus left plus 1, that will be 0 minus 0 plus 1. So here the max length will become 1 in this case. Now this right pointer moves ahead. When this right pointer moves ahead, it sees for another character, that is character A, and now again this character A will be put it inside the frequency map along with its incrementing the frequency. So that frequency will now become 2, and again the max frequency will be compared, means the previous max frequency and the current for the current character. So in this way, this 2 is maximum. So in this case, the max frequency will become 2. And once this become 2, now we will check for the condition. So window length is right now 2, and 2 minus 2 is 0, means 0 less than equal to 1. It means it is again the condition is true and the window is valid right now. So the max length will be updated again, that the longest substring with all the characters identical, all the identical characters, that is max length will become 2 in this case. Now this right pointer again moves ahead, and when this right pointer moves ahead, it checks for another character, that is character B, and it will be now going inside the frequency map. So character B will be moving with frequency 1, and for this current character C, now you can see here that how the maximum frequency is updated, uh, like what is the intuition behind updating it. So as we have already seen, means whatever the what we can say for max frequency is that max frequency is a variable which is saying that till now which is the majority times a particular character has been seen. What character is seen majority of the time? So a character has been seen majority of the times, that is 2 times. But as of now, B character is there, which is available for 1 time right now. So if it is compared with this previous maximum frequency, this maximum frequency is still 2 and it will not be updated. Therefore, the maximum times A has only been occurred. So therefore, maximum frequency will not be updated, and only we will be checking the condition, that is window length, that is 3, and minus maximum frequency, that is 2. So 3 minus 2, 1, 1 less than equal to 1, that is 2. It means the window is still valid. Means what we can see from here, this is the particular substring, and then this, if this 1B is replaced with a particular character B, then this can be formed a substring with all the identical characters. So this is again a valid substring, and or a valid window we can say. And in this again we will be updating the max length. So max length will be updated and it will now become 3. Now this right pointer moves ahead, and once it moves ahead, it checks for another character, that is character A, and for this character A, it will put its frequency, increment its frequency in the frequency map. So it will now become 3, and once it becomes 3, again the max frequency will be compared with the previous one and the current one. So this A has been seen 3 times till now, we can also see in the window, and the previous max frequency was updated was 2. So right now this max frequency will be updated, that will be with the value 3. And now if the condition is checked, so again this window length is 4 right now, and this max frequency became 3. So 4 minus 3, that is 1, and that is less than equal to 1. So condition is true, still the window is valid. As we can see, this if this 1B is replaced with 1A, then in that case what will happen is that it will form a particular substring with all the identical characters. So again this is the substring which can be formed. So let me just label it as this. So this is the particular substring, and it is having all the identical characters. So again we will be taking the length of this particular substring into consideration. So this when we take the length of this window, that will be right minus left plus 1, that is coming 4. So max length will be updated with the value 4. Now once it is updated, this right pointer will be moving ahead. Okay, right pointer moves ahead and it will check for another character B. So now B will be updated with its another frequency count, that will be for 2 times. And again when it is compared with the previous maximum frequency, so we can see also visually and also from here that till now we have seen a particular character A appearing most of the times, and B has only appeared 2 times. So therefore the maximum frequency will not be updated, and therefore when we check the condition, this window length minus max frequency, that is the window length is 5 and max frequency is 3. So when the difference is taken, that will be 2 less than equal to 1. And in this case we can see clearly that the window is becoming invalid, and in that case we will have to shrink this particular window. Now let me just remove this window from here. Now because this window is invalid and we will have to shrink this window, so first of all we will have to means this window will be shrunk with the help of left pointer. So left pointer is right now pointing at this particular character A. So first of all what will happen is First of all, this character's frequency will be removed, or we can say one of the occurrence of this character will be removed, so that will now become 2 from 3. Okay, and once this one of the occurrence of this a character is removed, we can just take this left pointer and move it ahead. This left pointer moves ahead. Let me just clarify one thing here, that one doubt can come to your mind that okay, if we are removing the occurrence of this particular character from here, then we should also decrement this max frequency, because a is now appearing for the in this particular window, a is now appearing for 2 times, so we should decrement it to 2. But no, that is not required, because even if this particular value, current value of the max frequency, if it is slightly greater than the real value, means we can see here that the a is appearing 2 times, but it is having 3 right now. It means it is slightly greater than the real value, so it will not be impacting the result, because see, two things can happen. Either this particular means whatever the next character will be coming, if it is the same character as the majority character, then in that case the max frequency value will become valid in that case. Or in case means the second reason, the second case can happen is that the window might become longer, and in that case, when the window becomes longer, in that case the window has to shrink again. So these two things can happen. So right now, as this left pointer moves ahead, firstly we will be taking the length of this window into consideration, so that length will be updated to means whatever the previous max length is there and the current max length, that will be 4. So that is already 4 we are already having from this particular window. So we can see from here that it is not impacting the result. Right now this max length is 4, and once it is done, we can just take this right pointer and move it ahead. So once this right pointer moves ahead, again the same process will be followed, and this particular character b will be taken inside the frequency map along with its frequency count increment. So this frequency count of this b will now become 3, and once it becomes 3, we can now just compare it with the max frequency. So both are 3, so no change will be done. And then this particular condition will be checked. So window length minus max frequency, that is what will be the condition, that will be window length, that is 5 minus max frequency is 3. 5 minus 3, 2. 2 less than equal to 1. Again the condition is invalid, so it means the window is invalid, and if the window is invalid, then again we will have to shrink it. So with the help of left pointer, this a characters, one of the occurrence will be removed from here, so that will now become 1. And the after this we will just take this left pointer and move it ahead. So again, see, we have not decremented the max frequency count here, and this left pointer moves ahead. And once it is done, now we will see from here that this particular window is here, and this is again if this particular character A is replaced with the character B, then this will become a substring with all the identical characters. And again this will be the again substring, again a substring with the length 4. So we will again take its length into consideration, so again the max length will be 4. So that's how it is done. And then this right pointer will move ahead. So once this right pointer moves ahead, now this it will see for A, and it will now take its count as 2. So A is 2 times present as of now. And then again it will be checking the same thing. So what it will see, it will be comparing the maximum frequency to, so it is still 3, because it is the count of B character, as it is appearing for 3 times. Most of the times a particular character appears. And once it is done, then again the condition will be checked. So what is the size here? The size is 5 minus the maximum frequency, that is 3. So again it is 2. So what will happen here? Again this particular thing will happen, means the shrinking will be happen from the with the help of left pointer. That's how the things work, and you can see without even decrementing the maximum frequency, which we do not have to do that. So without decrementing the maximum frequency, it is not impacting the result. Means whenever with the help of right pointer, even if the max frequency value slightly becomes greater than the real value, in that case as well, the result will not be impacted. The result will not come wrong. We are expanding the window forward with the help of right pointer. So therefore, two things can only happen. If the same character comes, then the max frequency, whatever the value is there, it will be the valid one, whatever it is the current value in it. And second thing, in case if the window becomes longer, then in that case the shrinking will happen. So only the what happens is this thing only delays the shrinking, not the result. So that's what I have to mention here. So here we have just seen the dry run, and now let's just go to the code part and let's implement this logic. Let us complete this function. So first of all, we have to take the size of this string. So that is s dot size will be the size of a string, and then we have to take the unordered map, that is the frequency map. So this is the unordered map. So let me just name it as frequency map. Here we will have to take the parameters, that is the character and the integer, and this will be named as frequency map. And then we will have to take the left and the right pointers, as we have to perform the sliding window approach. So here the left will be pointing at the 0th index, and the right pointer will be also pointing at the 0th. And what are the variables which we have to take? One is the max length variable, which we have to return at the end, and another is the max frequency variable, max frequency, which will be initialized with 0 right now. Now what we have to do is we have to just perform this thing till the right pointer is not going beyond n-1 index. Till the right pointer is less than n, we have to perform this process. First of all, what we have to do is we have to expand this window with the help of right pointer. So we will just take this frequency map, and inside this frequency map, for that s of right, wherever the right pointer is starting in the index, that there it is pointing, we will just take that character and put it inside the frequency map along with its frequency increment. And once we did this, after this we have to just compare the maximum frequency. So whatever is the maximum frequency, we have to update it with the previous, is comparing both the frequencies. So maximum of the max frequency, the previous one, and the current frequency. So what is the current frequency we are checking for? Current frequency means whatever the current character we have put it inside the frequency map. So that will be taken as the frequency map of s of right. That will be giving us the current frequency of that character. And this is how we will be checking the maximum frequency for every character, and at every point of time the maximum frequency will be updated, the max frequency variable. And once we have done this, now what happens is we have to check for the condition. So here we will be writing the condition here. What will be the condition? That will be the window length, the window size minus the maximum frequency. So how we can take the maximum frequency? Sorry, how we can take the window length? That will be right minus left. That will be taken as right minus left plus 1. This is how we will be taking the window length minus the max frequency. Whatever is the max frequency, that difference is taken, and if that particular difference is greater than that k, means whatever the at most times the at most replacements can be formed, if this number is greater than that k, then the replacements cannot be done. In that case, what we have to do, we have to just take the value, means one of the occurrence we have to delete from there. So that is s of left. With the help of left pointer, we have to just remove that one occurrence, and we have to remove this, move the left pointer ahead. And once this thing is done, in case if the window is valid, we just have to take the max length, we have to update it. That is max length equal to maximum of whatever is the previous max length is there, and the current we will just take with the help of right minus left plus 1. This way we can take, and we can just take this right pointer ahead. And once this is done, we have to just return it. This what we have to return. We have to return the max length at the end. And one thing which I have missed in the logic explanation part is why we are using the if condition. See, whenever with the help of right pointer, whenever the window is expanding, so window is expanding only with the by one position with the help of right pointer. So let's consider that we have expanded our window with the help of right pointer at this point of time, and at this point itself the window became invalid. So what we can conclude from here, that window became invalid because of expanding the window by one position only. And if we just shrink that particular window by one position, so obviously that window will become again valid. Again that window will become valid. So that's what we are doing. Now let us perform a run here. Accepted, and let us submit it. Is working fine. Now let's just understand the time and space complexity as well. So same here, that every character is leaving the window once and entering in the window once. So therefore time complexity is going to linear time, that is O of n. And talking about the space complexity, so again we already know that it is only consisting of the English characters, the English alphabets. So therefore means 26 characters only. So therefore the space complexity is constant in this case. This is all about this problem, and we will meet in the next video with the another problems based on the sliding window pattern with the more better problems. And Till then, just keep learning and keep growing. This is Aditya Pataria signing off. Thank you.